for a dust explosion.
Do you have explosive dust? Do you have too much explosive dust? And how much is too much? Hello, I'm Dan Clark. Today we're talking with Dr. Ashok Dastidar, Vice President of Dust and Flammability Testing for Fowsky and Associates in Burr Ridge, Illinois. Hello, Dr. Dastidar. How are you?
Good. How are you?
I'm well. We saw your article about combustible dust basics on ohsonline.com.
Sure.
Some industries have combustible dust and don't even realize it. Is that right?
Oh, that's very correct. We all realize that flammable gases or vapors are present, for example, methane gas or propane gas, but we really don't realize that simple things like coffee or sugar, fine metal powders like aluminum can also explode.
So if a business is creating some kind of dust and it's up on the rafters, the ceiling ducting on the equipment, and somehow it might shake loose and suspends in the air, then it might explode.
That is correct. You actually need 5 things for an explosion to occur. You need to have a fuel, which would be your dust in question. You need to have oxygen, which would be the oxygen from the air. You need to have some sort of ignition source, which could be a flame. It could be a spark from an electric motor. It could be frictional sparking or just a hot spot in piping or a process equipment. And then you need to have some sort of confinement. Building walls could be confinement. The piece of operating equipment that you're using, for example, a blender or a dryer or a mill or even just a dust collector could be the type of confinement. And then you need to have the dust suspended in the air somehow, which could be, for example, that shaking that causes the powder to fall off a high ledge like a light source or something. And when all those things combine together, you have the possibility of a dust explosion.
And I found this surprising. Many times, dust that comes from something that isn't normally flammable can explode.
Yes, it really depends on the surface area. For example, a steel rod may not burn. But however, if you make very fine steel powder, you could get that material to explode because of the extended surface area. So
how does an employer or manager know that they're at risk for a dust explosion?
Typically, most organic materials will explode. Most inorganic metals will explode. And there's some inorganic salts that could also explode. But ideally, besides the fundamental idea of organics exploding, the best way is to perform some sort of explosibility screening test. Mm-hmm. A go, no-go. Actual practical experiments are probably the best way to ascertain whether a material explodes or not.
Now, is this a do-it-yourself test? I know that you are in the business of doing this. Your company does this type of thing, but is it something that where you have to have a pro come in, or is it something that just an average Joe can do?
Well, there are safety concerns when you do this because you are dealing with flames and fires. So maybe if you're not well-versed or well-experienced doing this kind of thing, it shouldn't be something that you do on your own. It is a standard ASTM test. At ASTM, they have in E1226, they have a method for this explosibility screening. It's probably better left to do the test according to ASTM because you're using a fairly large pyrotechnic source, like a very large firecracker, to set off the explosion to see whether it would ignite or not. It's unadvisable, but if you wanted to look at it in the home, there are people that would do demonstrations on YouTube where they take, or actually I saw it on Mythbusters, where they actually dispersed some material, coffee creamer, and ignited it with a flame. That's a very crude method. It may not encompass all scenarios, and I wouldn't really recommend the novice to try that.
And men love to play with fire, so don't let them, you don't want to let them try this on their own, I guess.
Definitely not. I mean, if you're a professional on TV like Mythbusters or something like that, then maybe go ahead, but definitely it's something really that professionals should be doing.
You mentioned a go, no-go test. What is that?
Well, it's an explosibility screening test, and currently the way it's done in the ASTM standard, E1226, is that you take a sample of dust. You primarily look at the fine material, so you at least want it to be minus 500 microns, or less than half a millimeter, or you can go down as low as 75 microns, which is very fine. Then you can disperse this dust into a cloud inside of a combustion chamber. Usually the minimum volume you want to look at is 20 liters, which is around 5 gallons, or as large as 1 cubic meter, which is about 1,000 liters. And you'd hit it with this pyrotechnic igniter, a very energetic firecracker, and then you would measure a pressure increase inside of that vessel. And if the pressure increase is significant, usually around 15 psi, about 1 atmosphere overpressure from the explosion, you'd call the material combustible. And you do this over a range of concentrations to make sure that the material is not explosible across the range. If you happen to get an overpressure, if you happen to see a 15 psi overpressure from the explosion above atmospheric pressure, then you would deem the material to be an explosible hazard for a dust cloud.
Well, I can see this is where a pro really needs to do this, because the average person doesn't have a chamber that can measure pressures and things like that. So,
exactly.
If you don't want to have somebody come to your facility, can you mail a dust sample to somebody?
Yes. A lot of these labs we do it, of course, but a lot of these other labs that are in this field as well will accept samples that you collect on your own, probably from rafters, probably from light fixtures, or from a dust collector or fugitive dust elsewhere. And then you can put it in a Ziploc gallon freezer bag, double bag it, put it in a box and ship it, or preferably, put it in a non-breakable plastic bottle that you can put tape over the top, or a steel gallon paint can that you can seal up, and then ship it to a lab and have it tested.
Is there any special procedure in collecting a sample, or you just scrape it into a container?
You probably want to use a natural hair brush and dustpan, preferentially a non-sparking, non-static generating dustpan, and very gently scrape it into there, and then very gently pour it into either the plastic bottle, the sealable plastic bottle, or the sealable gallon paint can, or the gallon freezer bag. So long as you do things very gently, you'll be fine.
Okay. So the main thing is you don't want to change the nature of the dust. You can't add any water to it or change the moisture content.
Correct.
Do you need to fill up a gallon freezer bag, or just have a fistful of it in there?
Well, for this go-no-go test, you need about a half a pound to a third of a pound of material. But then if you wanted to progress along, that once you've classified the material as being explosible, if you now wanted to characterize the severity of the explosion, the intensity of the explosion, or the sensitivity of the material to initiate an explosion, you need significantly more material. And it's better to take it all at once, as opposed to having to then get up on the ladder again after a week or two and gather more material to then send in to characterize. You probably just want to collect as much as you can. You might need as much as 4 pounds to do some of the more complicated testing that might be involved in characterizing the explosive nature of the material.
And I also saw how to judge whether you have too much dust. If you can see your initials written into the dust, then you've got too much dust. Or if you can see your footprints in the dust, you've got too much dust. If you can't tell the color of the surface beneath the layer of dust, then you've got too much dust. Are those good indicators?
Those are actually very good qualitative indicators. Quantitative indicators would be found in NFPA, National Fire Protection Association documents like 499 or 654, and they typically recommend 1/32 of an inch of dust or 1/8 of an inch of dust. But then you'd have to go out there with some sort of ruler or depth gauge and try to calculate that. I guess the qualitative method, if you can write your name in the dust or if you can see your footprints, are very quick and easy methods where you can gauge whether you have too much dust or not, as opposed to taking out a ruler and measuring 1/32 of an inch or 1/8 of an inch, depending on the type of material you have.
If you've got a few feet like it's snow, you know you've got too much dust.
That's way too much dust.
Yeah. Can you tell us some war stories of what you've seen and maybe some disasters that you guys have helped avert?
I can't get into too much details because of confidentiality, but we've been in a lot of places where, for example, wood pellets are being made, and there's a lot of sawdust and a lot of wood flour that are being compressed into pellets, and there's a lot of fugitive dust that happens to be on the floor and on the surfaces. Those could all lead to an explosive event. One of the accidents that we investigated was an explosion in that industry from a dust collector. The dust collector that's collecting wood dust or wood flour exploded because of an ember from the pellet mill traveled back into that dust collector and then ignited the actual material inside. We've had a situation where we investigated someone pouring plastic resin into a vat filled with flammable vapors. And then they had an electrostatic discharge from pouring the powder into that vat that then ignited the flammable vapors that were present.
And that was just static electricity from the dust being moved?
That is correct. The dust being moved. Whenever you have two dissimilar particles that are rubbing against each other, the latex balloon in your hair, and rubbing it up and down, you can generate static electricity. And that static electricity, if it builds up enough potential or voltage, can jump from one surface to another, trying to seek ground. And that will generate a spark. And if that spark is energetic enough, it could ignite the powder or the dust that you're looking at. Or if you have vapors present, it could ignite the flammable vapors.
Mm-hmm. Well, for those businesses that don't really even know that they have a dust problem, what materials or substances just kind of sneak up on a manager and pose a danger?
I would say the people that are using buffers or grinders, or maybe they're doing some laser cutting of metal products, things that they wouldn't expect normally to explode. For example, metals, they have issues. Or if you're handling resins and powders in the plastics and polymer industry, you may not realize that you have material that breaks apart and becomes dust. You might be dealing with granules or pellets, and you don't really realize that you have dust present as well. It's primarily people that have unknown dust, or they didn't expect dust in their process and now have it generated due to breakage of their material or separation and accumulation, poor housekeeping. You only have a few percentage of dust when you're primarily dealing with coarse material, but then that accumulates over a 24/7 operation over the course of several weeks. That accumulates to dangerous levels, and then you just don't bother cleaning it up, and you can have an accident or an issue.
Mm-hmm. And statistically, how is the United States doing with injuries and deaths? Are we getting better, or is it getting worse?
Off the top of my head, I have certain figures that from the U.S. Chemical Safety Board, after several major disasters in the early 2000s, 2003, where you had an explosion at West Pharmaceutical, you had an explosion at CTA Acoustics, you had an explosion at Hayes Limmers, the U.S. Chemical Safety Board investigated dust explosions and found that between 1980 and 2003, there were 281 dust explosions. And I think that number is a little unreported. A lot of these events are not properly reported in the media and probably therefore not reflected in their tally. And it spans across a lot of industries, primarily food industries, woodworking industries, and metal producers. We'll see a lot of these disastrous events. Also what happens is you have a lot of near misses where you may not have a dust explosion per se, but you do have a fire. And what we consider is whenever you have a fire that includes dust, that was probably a near miss for a dust explosion. And the second tier hazard would be the actual dust fire that would occur afterwards.
Have regulations changed and have things improved because of the changes?
Well, that is a gray area. OSHA has come out with a national emphasis program where their inspectors are trying to focus in on this problem, and they're doing inspections and audits of facilities to see whether manufacturers are taking their due diligence and fiduciary responsibility to make sure they have a proper and safe workplace for their employees by recognizing the dust explosion hazard that might exist and then properly mitigating against that. So OSHA is doing something right now. They're still developing a law that would cover dust explosions, but that's not in effect now. But what people generally don't realize is the National Fire Protection Agency has several documents, NFPA 654, NFPA 61, NFPA 664, to name a few, that cover dust explosion hazards in the workplace. And these documents are part of your local fire code. They're part of your local building code as well. And therefore your fire marshal and your local building inspector are responsible for enforcing those. So while OSHA may not have a law currently in place and is just using general duty clause, which states that an employer should have a safe workplace as their stick for enforcement, the fire marshal, your local building inspector already have the tools in place to properly enforce dust explosion mitigation, dust explosion safety.
Oh, that's good. So you've got some local control because your fire marshal could come in and say, hey, that exit's blocked, but you also have a dust problem over here.
Correct.
But does quality vary going from jurisdiction to jurisdiction?
That's the unfortunate fact. Having it under OSHA would have a national standard that goes from C to C, whereas the enforcement of fire protection, NFPA codes, is pretty much left up to the individual jurisdiction and whether the municipality has enacted it into their local fire code or not. Also the experience, the knowledge of the local fire inspector, the building inspector on their ability to enforce that part of the code. So it pretty much becomes a hit or miss situation where some jurisdictions might be informed enough to police and enforce the policy, and other jurisdictions may not have that type of knowledge base and experience, so they don't enforce it. Although over the course of the last 10 years, I myself personally have seen information is being disseminated, and fire marshals and inspectors are becoming educated towards the hazard of dust explosions.
Well, I'm glad that it's now more top of mind than it has been. Doctor, is there any final comment that you could make for maybe a business owner that's concerned about potential dust in their facility?
Well, I just wanted to reiterate that it's one of those hazards which people overlook. They deal with sugar in their kitchen, or they deal with coffee in their kitchen, or creamer, and they don't really realize that the material could become a hazard when you're dealing with it at the 50-pound scale or 200-pound scale when you have it in a process environment. So I think that awareness of the issue is very important, and then realizing that there are steps that you can take to counteract it, going through the NFPA standards and then using ASTM methods to characterize and design mitigation systems is a very key and fundamental and fiduciary responsibility as a manufacturer and a facility owner to protect your employees, but also protect the capital investment from your shareholders.
And those business owners that want to get their own testing done, it's time for your shameless plug for Fauske and Associates. What's the web address if anybody's interested?
Well, you can visit us at www.fauske.com. That's FAUSKE.com.
Well, we appreciate the time you spent with us, Doctor, and hope to talk with you again sometime about explosive dust.
Thank you very much. It was a pleasure.
Our guest has been Dr. Ashok Dastidar, Vice President of Dust and Flammability Testing for Fauske and Associates in Burr Ridge, Illinois.